Moving on, our next session for the day is titled Digital Twin Systems Engineering, a Competitive Advantage. Our speakers for this session are Mary T. Lombardo, Vice President, Applied Research and Technology, Collins Aerospace. She's an experienced global innovation catalyst and technical strategist. Mary is no stranger to the India innovation ecosystem and talent. Mary has worked across multiple industries from building products to aerospace systems. Joining Mary is Dr. Christian K., Managing Director, Robert Bosch Semiconductor Manufacturing GmbH. Dr. Christian has been in his current role of MD in Dresden since July 2021. He studied electrical engineering at the Technical University in Ilmenau and the North Carolina University in Raleigh, and received his doctorate in solid-state physics at the University of Neuchâtel, Switzerland. Our moderator for this session is Subha Tatavarti, Chief Technology Officer, Wipro Limited. Subha has over 2 decades of rich experience in the IT industry spanning across product development, delivery, lifecycle management, cloud computing services, data technology, and analytics. In her previous stint, Subha led American retail giant Walmart Inc.'s product, technology development, and commercialization of enterprise infrastructure besides security, data science, and edge platforms. It's a pleasure to have you all join us this afternoon. Subha, the floor is all yours.
Hello, and thank you for joining our session on digital twin systems engineering. The concept of digital twin, a virtual model of process, product, or service, and its pairing with physical world has been around for some time. However, the advent of IoT and maturity of the ecosystem, including network and connectivity, software tools, and frameworks, has made it cost-effective and pervasive and imperative to businesses today. Today, I'm joined by Christian and Mary to discuss this very topic on how digital twin systems engineering could be a competitive edge. So welcome to the two of you.
Thank you, Subha.
Hello, nice to meet you. Yeah.
So so our first question, so this is to you, Mary. How do you think industries can take advantage of digital twin? And how do you see digital twins' role in reshaping the industry today?
Thank you for that question, Subha. I think for our industry, where we really see the advantage is when we start to connect our customers and our suppliers along the same infrastructure or platform. Many of our major OEMs in the aerospace industry are really driving this digital transformation, like digital twins, to support things like logistics, build management, improving our quality and product performance, and as well as on the research side, really helping to enable us to do true trade studies and also do performance simulations. So it really has been really transforming our industry in a tremendous and rapid pace, and the ability for us to truly do this will bring product to market in an accelerated pace.
Awesome. And Christian, I'm sure that you feel similar and you're seeing similar advantages, but would love to hear your thoughts on how it's affecting your enterprise.
Yeah, I'm responsible for semiconductor manufacturing. We are in the process of starting Bosch's biggest investment in its 130 history. And this is the build-up of a new wafer manufacturing site here in Germany. And this whole operation would not have been possible without a digital twin of the whole plant. This really supports us in having the oversight over a very complex setup with toxic gases, dangerous fluids, and a manufacturing footprint which consists of hundreds of machines that need to work seamlessly together. And by having a digital twin of the operation, we are capable of expanding the facility during the operation without having to rely on manual drawings, etc. So in that sense, it is a true enabler for such a complex operation.
Absolutely. And Christian, what do you think in your experience and in in using simulation and predictions from digital twin implementations for important product and operational decisions has helped you? And you touched upon a little bit about how imperative it is, but do you see the advantages in driving for that differentiation for you? And what features and capabilities will be important for digital twin implementations to fulfill their promise, as well as future competencies, gaining future differentiation for you and your company and enterprise?
Yeah, from our side, I would say that one of the crucial point is that within such a project, and we invested over €1 billion, you have to decide very early on whether you want to go into digital twins or not. So from day zero, basically, you have to have a clear vision. What kind of things do you want to do in the conventional way, and where do you go that extra mile and make sure that you have a digital twin of whatever you do. And after you have made this decision, you have to be very sure about the effort that are necessary to maintain that digital twin during the course of your project. So from our side, when we started the building, we decided very early on that we have a building information model that basically is a picture of the ground truth. This enabled us to move in production equipment and to have a virtual planning capability. But at some point, you have completed the first stage of the project, and then you have that danger of being somewhat not so diligent, and then you have to really stay on course and make sure that the ground reality is actually fitting to the digital picture, because otherwise you are losing that advantage of having this virtual representation. So we have to decide early, but then you have to stay on course, because otherwise you will end up with a somewhat semi-complete twin, which does not do the full trick. Yeah, and this is essential. So first, decide early, and then be diligent and stay on course.
Awesome, and I completely agree with you. Partial twins perhaps are more dangerous and a definite cost sink. Mary, would love to hear your thoughts, given your industry and your vertical specifically.
Yeah, I think our vertical's a little, well, I mean, it's a little different than starting from new. Much of our products are out in the field today. And so for us, it's really targeting those core areas that make sense for both our customer and for ourselves. And so one area that Collins has really made an investment is really in the area of prognostics, health management, right? So we're able to actually create what would be a digital twin of the products that we have on the aircraft. And we're able to take field data and be able to utilize that data to identify faults or challenges in the industry. And in some cases, for say one of our units, like an air cycle machine that's currently active on an aircraft today, we might get an error signal. And at this point, we don't know whether it's a fault or an actual problem. And what the digital twin allows us to do, when coupled with machine learning, it actually will allow us to predict whether, if it's an out of tolerance condition, whether that is in fact something that is showing like icing or actually a fault within the sensor. And so then we can take appropriate real-time actions that say, okay, that's a faulty sensor. We can ignore that. You can continue to fly, and being able to keep our customers up and flying is absolutely critical to our industry. It's how we make money, is by our revenue passenger miles. So I think that becomes a very important element to both our aerospace customers, and then also it's an important feedback mechanism to our design teams in terms of now maybe making sure that we build a more robust sensor in that particular application, or be able to, you know, respond to different situations that can be done in flight.
Fantastic. And I'm sure you, with your experience, you are probably gaining areas that you wouldn't have traditionally. And given the whole pandemic situation, what pitfalls do you see for someone who is looking to adopt digital twin? And what advice would you have for someone who is just or embarking on this journey?
Yeah, I don't know whether a Christian experiences the same thing, but oftentimes a lot of the pitfalls where people get really engrossed in the actual infrastructure needed to make the world all connected, right? And I think my advice would be to start small, right? Start with a factory, not start with trying to figure out how to enable all factories, right? Start at a point that's a very critical pain point for your industry or for your particular company, and then build off of that. You know, so in our situation, there's really a terrific opportunity to figure out, hey, you know, I've got an acceptance test and it has a low yield performance. Well, how do we build a digital twin to understand maybe the true design space in that particular area, and to be able to improve our throughput for that particular acceptance test performance that allows us now to be more profitable and to meet our customers' needs and intentions more readily. Start small. That would be my main investment, and then grow from that. Like, can I now connect that acceptance test back to my design, back to my material characteristics that are feeding into the finite element analysis that drives the ultimate performance, all of that, and grow it from the core, not grow it from, you know, a large infrastructure platform. I don't know, Christian, you see the same?
Yes, Mary, I think starting small in an agile way is certainly a good approach to something new. Maybe an additional point from my point of view, what we witness is that there's a lot of domain competencies in the different organizations, and you somehow have to prepare the organization for the surprises that they can get if you follow a data-centric, data-driven approach. And this, I would say, requires some management attention to make sure that when the digital twin is actually alive, that the organization is actually ready to harvest the benefits. And this can be sometimes difficult because you have people that are excellent in their field. They have been doing this in aeronautics or in semiconductor manufacturing for decades. And then all of a sudden, based on data transparency, they get these surprise moments. And then to actually harvest the fruits, I would say this is something which you need to prepare an organization for. Additionally, we see that we have invested in the past a lot in physics-driven modeling, and I would try to combine the two things. Yeah, having the data-driven modeling out of the digital twin, but in the combination with physics-based models, I think then you are really onto something where true prognosis is actually possible, because you basically can get the learnings from the past and enrich this with data-driven approaches, and then you have a truly powerful digital twin, I would say.
Fantastic. Absolutely. The data-driven approach to anything we do, especially in this case. You know, we're all aware that digital twin as a concept is very powerful, but it does require an ecosystem of tools and software, frameworks, and enabling technologies like cloud and connectivity, and with the advent of 5G. Where do you feel, and what is your assessment on the maturity of this ecosystem, and what are some of your learnings as you went about in dealing with this ecosystem of tools? And we can start with you, Mary.
Yeah, I think for me, a lot of the traditional modeling software like SysML, MathWorks are quite mature in terms of being able to actually model activities. I think the software that actually enables the interconnectivity between various systems that primarily are disparate, right? The manufacturing world has gone off and developed their manufacturing environments. The engineering world has gone off and created their PLM systems that, you know, the maturity around being able to connect them on a single platform, I think is still low. I mean, we're, you know, really need a kind of a backbone. And for a large corporation like us, where we may have 34 different PLM systems and 5 different MES systems, it gets quite complicated. And so I think the holy grail for us is really trying to figure out is how can I have an agnostic backbone that allows us to seamlessly interact the data from our factories back to our engineering, back out to the field, and really be able to have that be a fluid flow of information to really be able to capitalize on the benefits of a digital twin.
Absolutely. And Christian, would love to hear your thoughts given the massive scale at which you're operating.
For me, in terms of tools and systems.
Yeah, the assessment, what do you feel the maturity is? And where do you think we can make more investments in the ecosystem?
Investments is one thing, maybe a careful thought. I'm concerned about the techno-commercial side of things. Yeah, I mean, from a data science point of view, everybody would love to have a seamless flow of information, and then you harvest the full benefit. From a commercial point of view, you have different ideal operating points. Yeah, you don't want to share everything with everybody, and to have the right balance between free exchange of information, but at the same time being able to have a competition between suppliers and deal with different customers. This kind of application-specific tailoring of exchange of data, this is really something where I feel as an industry we have to spend some thoughts on it. Yeah, because I think everybody is agreeing trade secrets need to remain trade secrets. On the other side, information flow across the value chain is a very powerful tool. But if you want to exchange your supplier, then you still need to be able to do this. And this kind of techno-commercial free choice is something where a lot of systems at the moment, they give you this lock-in situation that you might not want to have. Yeah, and this is actually one of the points where a small proof of concept then at some point comes to a difficult situation when you want to roll out this proof of concept in the overall organization, and then the purchasing department comes and the sales, and they say, hey, this is only one supplier, but it doesn't work with the other supplier. And this kind of techno-commercial tuning of the systems, there I feel some lack in the tools. Yeah. Technically, a lot of things are possible in the specific case. Yeah.
I 100% agree. I think there are 4 like major challenges with the overall like digital twin infrastructure, right? Certainly intellectual property, and I know that there are some standards coming out that are actually enabling, you know, that interaction in an encrypted fashion, so you're not, you know, yielding your full IP concerns to the world or the community or the industry. The second is really around cybersecurity strategies. We're really talking about cross-domain enablement here, and that becomes very complicated because I think even within our own systems, we want to be sure we have you know, a cyber secure, but now we're trying to do cybersecurity across a much broader infrastructure, and that becomes very, very complicated. The next is kind of where Christian was going, is really also around the contractual knowledge. Like, how do we actually write contracts for a digital twin enablement opportunity? And last is making sure you have clear understanding of the economics. If you're building this for an entire infrastructure, how much will this cost you to maintain moving forward? And what is your return on investment for doing this? And there needs to be sort of clear deliverables on all of that.
Absolutely.
I see, Mary, we speak the same language. Huh?
Absolutely, an open ecosystem makes complete sense. So I'm so intrigued to know, what do you feel are the benefits that you feel that have derived? I know the entire conversation was about benefits, but would love to hear if there is any time that you can say this is this one big massive benefit. How would you quantify, and what would that be? And this is for our colleagues and our partners that are probably wanting to embark on this journey. And how do you feel your implementations within the organization has driven your businesses to the next level, or perhaps deal with the pandemic situation we had in the last couple of months and years? Mary, you want to go first?
Yeah, sure. You know, I think some of the benefits, and I'll speak from a sort of a engineering perspective, and then Christian can probably speak from an operational perspective. But I think from an engineering perspective, what we're really seeing is kind of a changeover in the way in which engineers need to work moving forward, right? Historically, we've been really around a design, build, and test, and then build, test, and then build, test. And what we really are moving toward is a model, analyze, and build. And so that you're limiting the amount of redo loops, and you're actually able to reduce your time to market, and you reduce your overall costs of analysis, cost of acceptance testing, cost of certification, components, and even at a system level. I think if we then look to see and acquire a lot of information from the entire product lifecycle, we're now able to make more intuitive conversations. If we're able to take from the manufacturing floor their tolerances, we're able now to build and optimize the upfront design because we're doing it in a real world situation. That is very powerful because it allows us to optimize our costs, optimize our designs, and really provide a more robust offering to the industry.
I agree 100%. Go ahead, Christian.
I would like to add 2 points. From an operations point of view of a fairly complex manufacturing plant, we could save in installation of complex equipment roughly 20% by having this digital representation of the complete factory. And this, of course, in the current semiconductor supply crisis is highly welcome, because it really shortens the ramp up of the facility. Something more downstream, but equally or even more important, based on the detailed understanding of the product, and this relates to what Mary said, we started to have what we call virtual testing or fast release of products, because we understand the products based on its digital twin much better. And in automotive, obviously the safety requirements for something like an electrical steering or a braking system is very high. And we could actually reduce the testing time by having a more data-driven approach, and reduce time to market because the qualification does not involve winter testing on vehicle level, which obviously takes a lot of time. So this was highly welcome and relates to the testing topic that Mary actually mentioned.
Fantastic. And I think anyone who's watching our session will be more convinced, if they were not already, the implications and the advantages of adopting digital twins. So thank you, Mary. Thank you, Christian, for your time. I myself learned quite a bit from this conversation, and thank you for being part of this session. It was great.
Thank
was a
you. Thanks for
pleasure.
having us.
Thank you very much. Bye-bye.
Bye-bye.
Thank you very much indeed, Subha, Mary, and Dr. Christian, for that amazing discussion on digital twin systems engineering, a competitive advantage.